If we have an expression like this, where I've put a question mark here for x, which is like the example on the first slide, then what will happen is the type checker will see x and it will say, I don't know, that is some type t1. And then the checker says 1 and it says, I know that's number. And then the type checker says, well, I could give this whole plus expression the type num as long as t1 turns out to be num. And so somewhere on the side, it records the information that t1 has to be num and carries on. And then, because this question mark is also the same thing as where the t1 came from, then the overall type can be num arrow num, and the type checker is happy. So the process here is whenever we write question mark, we really make up a type variable, like t1. And where we used to check whether a type was equal to some other type, now we will have to, in the case of a type variable, install some assignment. Make that type, record that that type variable has to be equal to some other type as we go. Right? And that process of equating types instead of just checking that they're equal, that will give us inference. Here's another example. I've got x with a question mark, so that's going to be some type variable t1. And as we type check the body expression, true has type boolean, 1 has type num, x has type t1, because we made up a t1 for this question mark. And then we have to make sure that the type of the then expression and the else expression are the same. So we will end up equating t1 to num again. And then we will return that same type, either t1 or num, because they're equivalent, as the type of the if expression. And then that will let us give a type to the whole lambda expression, again because this question mark was t1, it's t1 arrow num, or equivalently num arrow num. How about this example? We make up a t1 for the question mark here, so that the type of this x is t1. And then we also get 1 and t1 again for this other x. For the whole if to be well formed, this t1 has to be bool. Right? The type of this expression has to be bool. But also these two types have to be the same, num and t1. And t1 can't be both bool and num, so there is no type that we can give to this overall expression. How about this case? Y has some type t1, and so we type check the body of the expression, and that's t1. And the body of a lambda doesn't have to be anything in particular. We just use that in an arrow, so we end up with just the type t1 arrow t1. And in fact, there are many cases that we could put here. We could put num here to get num arrow num, or bool to get bool arrow bool. We could even say that y is a function from numbers to booleans, in which case this overall function takes such a function and gives back such a function. So when it's ambiguous, what will happen with our inference is that it'll just leave the t1 there effectively, which will mean you could put any type here.